This last slide from the last time is just a review of that property we were discussing last time. Yeah, it's a property of the real numbers. You have the third one, the pink one, distributive property. When you have a number multiplying a sum within a parenthesis, you have to make that number multiply each one of them. Yeah. So they all have these names, right? Commutative property means A plus B equals B plus A. You can, the order of the sum doesn't matter. Associative means you can add them first and then add them later. And then the distributive is the relationship between the sum and multiplication. Yeah, and then that video was this teacher was kind of funny. He was explaining to us like how you shouldn't forget how to distribute the multiplication. And so the next slide shows how I used this last time. Just like A times B plus C is equal to AB plus AC, right? AB means A times B, and then AC means A times C. So you have, if you take 4, for example, 4 as A, you have 4 times 2x plus 3 within parentheses. You use a distributive rule, right? So you have 4 times 2x plus 4 times 3. So that's going to give you 4 times 2, that's 8. So 8x plus 12. Is that all right? Mm-hmm. So you can go from 4 times parentheses, 2x plus 3, close parentheses, to 8x plus 12. You can also go backwards from 8x plus 12 back to 4 times 2x plus 3. Yeah, so from the top down, that process is multiplying it out, expanding it. From the bottom up, we are actually trying to factor it again. Try to figure out what were the smaller parts that gave me that longer product, right? This is what I did. I don't know if you guys remember from last time, but it's 3x plus 6. I said it was 3 times x plus 2. So I went from the bottom level to the top level, working backwards, kind of. Yeah, okay,
So when would you use something like this, like trying to find the small ones? Because you could say, it's 4 times 2. It could also, that's a bad example.
Or 2 times 4, right? Or something like that. Why?
Yeah, like how do you know? Or something like it's like 16x. Well, it could be 8x times 2. It could have been times 4. It could have been like all of that. How do you know those, and when would you use it? Where that variation is it going to be?
All right, that's a good question. Actually, I usually don't want to factor because I'm like, I don't know what's the hidden number here multiplying, right? But there are 2 cases I can think of that might be useful. One is when you have a numerator divided by a denominator, right? You have a fraction and you want to simplify the fraction. You want to try to find common terms in the product in the numerator and the common terms in the denominator so that you can cancel them out. So that's one place where like factoring is useful, right? Why would I factor? I have a polynomial divided by another polynomial. I want to see if I can actually make them smaller, like in the sense that if I can cancel similar terms in the numerator and denominator, then yeah, I'm simplifying the fraction. So it's the same as saying, why should I write like, 140 divided by 280 if I can just say 1 divided by 2? 1 divided by 2 is more manageable. That's why we would factor. That's one case. The other case is later on, there will be exercises in solving equations. And a lot of the equations are something crazy here on one side equals to 0. So how do you solve this? If you can write whatever is on the left side as a product of terms, the product of different terms is equal to 0 as long as one of the items is 0. Do you see what I mean? You will have like sometimes you have some crazy polynomial here and then say equal to 0, solve for x. So instead, like, how do I solve this, right? So then we are going to get that expression, that polynomial in x, and try to factor it into a product. And then we'll say, now I solve for each part, set each part equal to 0 as a solution. So these 2 cases, one is for simplifying fractions, rational expressions that have a numerator and denominator. And the other one is to solve like equations like something equals to 0. So then I want to make this something into a product. All the other cases I say, don't try to factor anything because it's like, what's the point, right? We don't. Is that okay? Okay,